Everyone has a role to play, everyone has their own expertise.
One of my favorite things is just getting to know the team better and everyone just having a good time.
We started discussing a CSAR-like campaign back in 2016, and that was a small group of people that gradually grew.
We have representation, I think it's from 8 universities that are here, and we have people from Sweden that are collaborating with us up here.
Collaboration is, of course, really important because these systems are so complex, so you need this huge interplay of different instruments. You need the remote sensing sensors to give you the spatial scale, and you need these cloud probes or in situ instrument to give you the detailed process information.
So I'm mostly interested in the effect of what the atmosphere looks like at the upstream boundary, so over the ice before it comes out over the warm water. During the actual field phase, we've been mostly working with forecasting.
Weather briefings are important for several reasons. For one, our campaign targets cold air outbreaks, so we want to make sure that we are flying into conditions that are conditions that we want to observe. For two, it's important for flight safety, so we have to know that takeoff conditions are favorable to take off, and that it'll also be safe to land once we return back to Kiruna.
You can see cold air outbreak over here. You could see the convection right at the edge of the Arctic frontier, and then you can see the convection of the warm sector here. So those are kind of the landmarks that we'll be flying over.
Myself and one other faculty member at the University of Michigan joined this project to look at water isotopes in the clouds, and I think the most interesting thing I've been able to see is as soon as that super dry air reaches the open ocean, we instantly see the air become a lot more humid, and with the isotopic measurements that we can make, we can even see that that humidity is coming directly from the ocean water, which is pretty awesome.
I'm involved with making measurements of aerosol. These are small particles. We measure their size and concentration to better understand cloud processes that occur over the Nordic seas as part of the CSAR campaign.
It is the data would show us the science, and then the science will tell us the story, and the story will lead us to a better forecasting in the future.
Besides that, there's a large staff from NCAR here. It takes a lot to keep the C-130 running.
Our role as pilots is really as facilitators. We're there to make sure the mission gets executed in a way that supports the scientists, and that means collecting the data that they're looking for, finding the weather phenomenon that they're trying to study, and coordinating with ATC to make it happen.
On the ground, we'll sit down with the PIs and we'll kind of try to understand what their intent is for the science mission, and then take the flight plans that they've come up with and then kind of mold them a little bit to make them work for the environment that they want to operate in.
I'm acting as a software engineer, and I'm also acting as a data manager in the field. On the software engineering side of things, we have a network on the back of the plane. It's pretty similar to the network you have in your house, except for instead of having a local internet service provider provide the network, we have a satellite to provide the network. I make sure that everything's configured, people have instrumentation they're connecting up to that network. Then after a project, my data management role takes over, and I download that data file. I actually bring a disk with me, a little USB drive, might be something you have at your house. Bring it down to a laptop we have set up on the ground to process that data and get it out to all of the team.
But like the true heroes behind the mission, I think, are the maintainers or the techs. The plane's being worked on right now. We continuously run into small issues that have to be fixed and worked, and this mission wouldn't have happened without hours and hours of work that they put in to get this plane ready to be out here and fly in these austere conditions.
And Another thing that we're doing is we want to make sure that our science has an impact on the next generation, because science takes longer than just one generation to fully blossom.
When I was an undergraduate student, I did not have a chance to participate in some large field campaign like this. So when I wrote my proposal, there's one thing that was clear to me. So I needed to put some budget there to support a few students, so that we can do this education and training for our next generation of the atmospheric scientists.
Being able to be here is definitely a very rare opportunity. As an undergraduate, I'm involved with the quality control for the drop-on system. So basically I'm going through after drop-ons are released from the C-130 and checking the data, making sure it's all good with pressure, temperature, relative humidity, and all of that.
It's really cool hearing just the science that everyone brings. There's people focusing on cloud microphysics or different dynamics, and it's all really cool to see it mesh together as one cohesive team.
Whether you're the PI of the project, whether you're an individual scientist, whether you're an instrument operator, whether you're a technician or you're a pilot, we all come together to get the best possible data. We rely on each other and we work together great as a team. So the important thing to realize, there's a role for everyone in science.